RISAFoundation utilizes a comprehensive set of modeling tools for the simple creation of a variety of foundation elements. Model foundation elements such as retaining walls, spread and combined footings, piles, and mat slabs. In this video, today I'm going to show you how to analyze and design retaining walls in RISAFoundation. So let's go ahead and get started. So the first thing I'm going to do here is I'm actually going to modify my drawing grid because I'm designing a basement wall. This is a partial basement structure and the length is about 80 feet. So I want to include the full length of my wall here. And to modify my grid, I can just go to the Modify tab here and choose Drawing Grid. I'm just going to change this to be 80 feet. So to start drawing walls, I can click on the wall footing icon here, and there are some pre-loaded wall properties. However, today I'm going to add an additional wall footing definition. So to do that, I can press on this icon here, and it's going to take me to this wall footing definition editor page. So this page is really helpful because it helps the user understand the inputs in the different variables for your wall footing. If I come into my wall footing definition spreadsheet, I do have the option to add an additional wall footing through the spreadsheet as well. Just by pressing enter, I can add a new wall footing here. If we call it basement wall, and I can change the type, and I could input all the geometry in here. Also within the spreadsheet, if I wanted to just click the red arrow right here, I'll also be presented with that same dialog. So this dialog looks a little bit different because it's showing me the strip footing. So RISAFoundation, you do have the option between a retaining wall and a strip footing. The main difference between those is that the retaining wall will consider the lateral earth pressure, whereas the strip footing is looking just at the gravity analysis. So for this basement wall, I'm going to want to consider those lateral earth pressures, so I'll go ahead and choose from this drop-down menu of the wall type and choose to be the retaining wall. So here on this first general tab, I have the option to specify the wall thickness as 18 inches. Since this basement wall is supported at the top by the floor diaphragm above, I'm going to go ahead and say that this is propped. And we'll say this wall is about 18 feet tall, and the soil will come up to about 17 feet. We'll leave the saturated soil height at 6 feet. We also have the option to specify whether or not the footing is poured congruently with the wall or in two separate pours. We also have the option to specify whether or not that interface between the footing and the wall is rough or smooth. We can specify our toe lengths and our heel length. I'm going to set the toe at 3 and our heel length to 4. I also have the option here to specify the concrete material or a masonry wall. But in this instance, I'm going to use concrete. I'm going to change the wall construction material to normal weight 4,000 concrete. I'll want to change the footing as well. Now that I have this general material input, I can come to the Soil tab in my Wall Footing Definition Editor, and here I'll input all my soil variables. So these variables are what you'll obtain from your geotechnical report. We have the option here to choose the ranking or Coulomb method. I'm going to keep the ranking method selected. We're not going to consider friction. In this analysis here, we can specify the soil toe depth. You'll notice that we've got 3 different soil inputs here, and so the program can analyze our lateral earth pressure coefficients for 3 different soil types. The soil that is at the toe of the retaining wall, the soil that is at the heel of the retaining wall, and then also that saturated soil at the heel of the retaining wall. I'm going to leave the K values blank because the program will automatically calculate those. However, you do have the option to input those values if you know them already. So for the soil densities and the internal friction angles, I'm going to leave these all as the program defaults. I will change my surcharge load to 100 PSF. Now we'll swap into the Details tab here of my retaining wall. So I've got the option here to specify if I want a single layer or each face for my retaining wall. I can also specify if I want the outer bars to be vertical or horizontal. In this case, since my wall is spanning vertically, I'm going to want to keep those outer bars to be vertical. So then the soil side of my wall cover will be 3 inches and the interior cover will be 1.5 inches. The program is going to optimize my vertical bar spacing here based on these in the minimum and maximum values that I input for this. Now in this dialog here, I have the option to specify the reinforcement for the footing. I also have the option of each face or a single layer. I can specify that longitudinal bar to be 12 inches. We can specify our bottom bar spacing and top bar, and that'll be optimized based on our minimum maximum spacings. I'm going to increase that to number 8. So I was able to input all those variables without having to do it through the spreadsheet. So I can come back to the model view to draw my wall footing, and I can choose this from the drop-down menu, basement wall, from what we just created. I can choose apply, and then I can just draw based on clicking nodes from our drawing grid. So now we have this plan view of our retaining wall. Even though RISAFoundation is a plan-based program, you can still switch into the isometric view to see the actual 3 dimensions of the retaining wall. The soil definition spreadsheet is where the bearing of the retaining wall at the footing will be considered. So right now we have a default soil definition. We've got a subgrade modulus of 100 and allowable bearing of 3. I'm going to switch the allowable bearing to 4 for my specific project. I can come into my load combination spreadsheet and I can see that we've already got dead load and live load and hydrostatic load combinations already considered. So we've already got the hydrostatic load considered in our model here, and that was through the lateral earth pressures that we specified in our retaining wall editor. Now let's apply some dead and live loads. So to do that, I'm just going to use our line load tool. So we'll draw line loads, and today I'm actually going to keep my loads applied on this wall concentric. You do have the option here to specify, say, a moment about the z-axis. I'm going to choose a 1 kip per linear foot dead load. I'm going to choose to keep this dialog open because I'm going to need to apply my live loads. And then I'm just going to apply the line load by clicking the 2 nodes at the base of the wall. And you'll see that it automatically populates that load at the top. Now I'm going to go ahead and apply my live load of 0.5 kips per linear foot, the same as we did before. So we'll go ahead and run the analysis for this retaining wall. You can view all the results for your retaining wall through the spreadsheets, but if you are more of a visual person, you can also view the results in the detail reports. To view, click the base of the retaining wall. First, view the introductory graphic of the retaining wall. So it's giving you all the details you need here to construct your wall. It's giving me the reinforcement spacing, it's indicating that it's propped, and all of the spacing definitions are all there. So that's a great image. For example, you could pass off to a draftsman and then they could go ahead and begin drafting. Up here, choose which load combinations to view. When I come down, I really like this loading diagram here as well. This shows me the actual lateral earth pressures that were calculated as well as the bearing pressures. We can keep scrolling down and get some more material properties here. As I keep scrolling, we've got the footing design and it gives us the soil bearing check. So in this particular detail report, it is not checking over turning or sliding, and that's due to the fact that this wall panel is propped. At this point, we've completed the design and analysis of our foundation structure. For more information on other topics, please visit our website, RISA.com.